A revolution in flight is quietly taking shape, and its impact could stretch far beyond what traditional aviation giants ever imagined. With low upfront prices, cheaper operating costs, a network of intelligent charging stations, large-scale automated manufacturing, and software systems built for safety first, Tesla's super electric plane isn't just another aircraft. It's a signal that the skies are about to open up in a way that challenges Boeing's decades-long dominance. What's coming isn't simply a new aircraft model. It's the start of a more affordable, efficient, and accessible flying era, one that's closer than most people realize. Before we get deeper into this transformation, a quick note of appreciation. If you enjoy clear, practical insights into real technology that delivers real-world value, please consider subscribing to WestTech. Our goal is to reach 221,937 subscribers, and your click helps keep this mission alive. Turn on notifications so you'll never miss a future deep dive into what's truly reshaping transportation and technology. Now, let's explore one of the biggest surprises of all, the price. The Tesla super electric plane carries an astonishing starting tag of $83,595, a number that fundamentally shifts who can actually own an aircraft. To put that in context, a brand new Cessna 172, the workhorse of general aviation, costs anywhere between $400,000 and $600,000. The Piper Archer TX sits in the $400,000 to $520,000 range, and a premium Cirrus SR22 pushes well over $1 million. Against those benchmarks, Tesla's entry cost lands somewhere between 1/5 and 1/10 of the price of traditional piston planes. That's a staggering difference. This pricing doesn't just make the dream of flying more attainable for wealthy pilots. It completely redefines the market. For the first time, individuals, flight schools, local charter services, and small businesses could realistically afford to own an aircraft. The Tesla super electric plane drops the entry barrier, so low that it invites thousands of potential operators who were previously priced out to join aviation rather than watch from the sidelines, and the infrastructure to support them. It already exists. The United States has roughly 19,500 airports, with around 5,100 open for public use. That means most of the physical network needed for a decentralized air system is already in place, with a small, affordable, and quiet electric plane. Local businesses or flight clubs could operate near highways, industrial areas, or even small towns, using existing runways to run point-to-point services. There's no need for massive new airports or extensive government projects. The hardware of aviation is already laid out across the map. Looking at the broader economic side, the General Aviation Manufacturers Association GAMA reported about $31.2 billion in aircraft deliveries in 2024. That number represents a market largely built on high price tags. But what happens when a plane like Tesla's drops the cost of ownership by 80 or 90%? Pent-up demand that's been waiting for a cheaper way to fly could finally be released. The people and small companies who once saw aviation as an unreachable dream could now buy in, fly regularly, and create entirely new business models around local air travel. That's where the real transformation begins. When the purchase barrier falls, a whole new layer of short-range flight becomes practical. Commuter hops between nearby towns, fast on-demand taxi flights, and light cargo deliveries covering just a few hundred miles. All of this can be done using the same public airports already scattered across America. And with a lower per-flight cost, operators can run multiple flights per day, increasing utilization rates and turning what was once a luxury into a steady, profitable service. Now, Boeing may not build small aircraft in this category, but that doesn't mean it's unaffected. Tesla's new platform creates what you might call edge disruption. It starts at the fringes of Boeing's empire, the short routes currently handled by small charter companies or turboprop operators. Over time, these short routes could shift to electric planes. reducing demand for the larger aircraft that feed regional routes into Boeing's commercial network. There's also a second, less obvious ripple effect, one that could touch Boeing's $20 billion global services division. This segment profits from maintenance, parts, training, and aftermarket support. But if short-range flying moves to electric aircraft that require little fuel, minimal maintenance, and almost no engine overhauls, the service revenue linked to these small route operations could shrink. It's not that Boeing will suddenly lose its wide-body market, but parts of its ecosystem may erode quietly from the bottom up. At this point, you might wonder, a cheap sticker price is impressive. But what really determines whether Tesla's plane succeeds isn't the upfront cost. It's the cost per flight hour, the operational number that decides who survives in aviation. So how exactly does an electric aircraft beat gas-powered planes on that front? There are two key reasons. The first is simplicity. The electric motor powering Tesla's superelectric plane has only a few moving components. It doesn't need oil changes, spark plugs, fuel injectors, or the complicated air-fuel mixture systems that internal combustion engines depend on. That mechanical simplicity means maintenance becomes drastically cheaper and downtime is reduced. Lessons from electric vehicles already show the pattern over their lifetimes. EVs tend to cost about half as much to maintain as gasoline cars. Applying that same logic to general aviation paints a promising picture. The second advantage is the energy cost itself. Electricity is inherently cheaper and more efficient than aviation fuel. To visualize this, let's use a real-world example. The Pipistrel Velis Electro, a certified small electric plane, consumes roughly 22 kilowatts of battery power for about 50 minutes of flight. In mid-2025, the average commercial electricity rate in the U.S. hovered around 12 to 13 cents per kilowatt hour. That means a full charge for nearly an hour of flight costs between $2.60 and $2.90. Even when you include charging inefficiencies, you're still talking about just a few dollars per flight hour. Now compare that to a conventional Cessna 172, which burns roughly 9 to 10 gallons of fuel per hour. With aviation gas priced at about $6 per gallon in late 2025, that translates to $55 to $65 in fuel costs per hour, before adding the cost of oil changes, spark plugs, inspections, and other upkeep. That's not just a small difference. It's a revolution in the economics of flying. This massive gap in operating cost is what gives Tesla's aircraft its long-term advantage. Lower variable costs mean operators can price flights more gently, open up routes that were never profitable before, and still make consistent income. Imagine routes between towns 50 to 150 miles, part places with small airports but no regular service. Suddenly, those flights make sense. With low charging costs and minimal maintenance, a local fleet of Tesla super-electric planes could fly multiple legs a day, creating steady revenue streams where none existed before. The U.S. alone already has over 5,000 public-use airports and roughly 19,500 total landing facilities, which means the origin-to-destination network is essentially ready to go. No massive new construction is required, only the addition of smart electric charging and software systems to coordinate traffic and scheduling. Once those are in place, fleet operators could easily achieve high daily utilization rates, turning each plane into a small but efficient money generator. This model combines high frequency, low cost, and broad accessibility, three traits that Boeing's large aircraft portfolio doesn't focus on. Boeing dominates the skies with giants like the 737, 787, 777, plus corresponding cargo variants. These machines are engineered for long-haul routes, high passenger volume, complex logistics, not short commuter hops or air taxi operations. That's where Tesla's new plane finds its sweet spot. As short-range flights electrify, Boeing's indirect exposure grows. The shift might start with regional training centers, small operators, or local logistics networks. But over time, it could ripple upward through the value chain. If small cargo or passenger connections between towns move to cheap electric platforms, larger planes will handle fewer feeder flights, And airport ecosystems will change to reflect that. Fuel costs further amplify Tesla's edge. In 2025, jet fuel prices on the U.S. Gulf Coast averaged around $2 to $2.20 per gallon wholesale, but retail prices at fixed-base operators, where general aviation aircraft refuel, are often much higher. That means even for short hops, operators of gas or turbine aircraft face heavy power fuel expenses. Electric planes sidestep that completely, relying on grid or renewable power that can be generated locally. Over hundreds of flight hours per year, that difference translates into tens of thousands of dollars in savings. All of this points toward a fundamental reshaping of aviation's business math. Instead of being a luxury reserved for the elite, short-range air travel could become a routine part of regional mobility, priced closer to rideshare trips than private charters. Tesla's vertically integrated model helps make this possible. Manufacturing at industrial scale drives down unit cost, while the company's software ecosystem, from flight safety algorithms to smart routing and predictive maintenance, ensures each aircraft operates efficiently with minimal human oversight. That's also where Tesla's broader ecosystem matters. With the same charging architecture shared across cars, trucks, and potentially aircraft, the company can leverage its growing soup